himself in.
Okay, here we go. Y equals what? A times sine of B theta. Doesn't that look like, wow, a lot of stuff in there?
Yep.
It's like
Yeah,
a
guess what? I'll make it really easy for you today. Come on over here and let's do this. See this A? We're gonna make it 1, Bryce,
Yeah.
1 times sine of, not B theta, I'm gonna make it 1 theta. I'll make it 1 times sine times 1 theta. Guess what that's called? No guesses. Still no guesses.
Parenting?
Parent. That's your parent. Remember the parent function? It's the most basic sine function I can give you. So what I would like you to do is this. We're going to start by graphing just that. Not A. I'm not going to make the A a number like 2, 3, 4. I'm not going to make the B a number like 2, 3, 4. I'm just going to keep it simple for you. Y equals 1 times sine of 1 theta. Now, what does this say right here? Theta will be in what? Don't think degrees. Think what? Radians. So you put radians in is what you do. Okay, so now, here we go. Okay, thanks, you. Okay, all right, so now, hey, I just started your notes tape. Now what you need to do is this. Since we're going to graph it, we don't know anything about this, so we're going to start slow. What we're going to do, we're going to make a table. Yeah, when you graph, you make tables, okay? So here we go. Would you please do this though? Somewhere on your paper, go like this. And then make this unit circle because you're going to end up putting the quadrantals in. And the quadrantals, they land right on the XY axis. This point is what? Remember the radius is 1. 1, 0. What's this one? 0, 1. This one. Negative 1, 0. And 0, negative 1. Okay? Just have that by you all the time. Okay? Now, what you're going to do, and I know I didn't make a table for you, but you're going to make a table. And your tables usually they go up and down, but I'm going to go this way. Okay, you are going to put in numbers for x usually, right? But not today. You're putting numbers in for what? Theta. You're putting angles in. You're going to get out a y value. Okay, so here's the deal. What? Say that again. You're gonna come up with these right now, but I'm gonna guide you through this. Ready? I need you to put in a radian that would be really super easy for us to find sine.
Pi.
Sine of what?
Half pi.
Half pi would be easy, but even easier?
Pi.
How about a radian of 0? Let's just find sine of 0. Okay, now, do you guys remember that? Here's what I'm doing. My function is y equals sine of theta. Okay, so you're going to put what in for theta? 0 radians. That's right here, by the way. And sine is just y over, say it, r. Okay, you ready? If you put a 0 in, you're here. Where's the y value? 0 over, which is? Oh, sine of 0 radians is 0. Okay, well here's half a pi, here's 3 halves pi. Zero's right there. You get what? 0. Hey, please ignore these dots. These red dots mean nothing, okay? Okay, so what's another easy one? Go to that one up there. What's that one?
Half pi.
Half a pi. Go to the 90, half pi. If you do the half pi, half pi, I know you can't see it now, but let's try slide up. If you do half a pi, sine of half a pi is y over r. 1. Okay? So pi over 2, 1. Okay, if 0 is easy and 90 is easy, so is 180. Well, what's 180 in radians? Pi. So let's put pi, sine of pi. It's always y over r, isn't it? What's 0 over 1? 0. Right here. Pi 0. Okay, what would be next down the list?
3 pi over 2.
Yeah, 270 or 3 pi over 2. So put in 3 pi over 2. Tell me, what's y over r?
Negative 1 over 1.
Negative 1 over 1 is?
Negative 1.
Negative 1. Okay, that'd be about here, somewhere. Yep, right there. Okay. All right, I'm almost around the circle. I'm right here now. 2 pi. A complete circle. You went all the way around 2 pi. What's sine of 2 pi? Y. Y over 1. 0 over 1. 0. Right? Now guess what? In trigonometry, angles just keep going on and on forever. So if I went from 0, 90, 180, 270, it's 360. Well, guess what? This is now 2 pi. What's this now? What is it? 2.5 pi, but 2.5 pi is 5/2 pi. Guess what the answer for 5/2 pi is? 1 over 1. It's back to 1. Do you see something happening here? 0, 1, 0, negative 1, 0, 1,
0, negative 1.
0, negative. It's a pattern. It's a pattern, guys. So yeah, I could continue this. Okay, so here we go. 0, 1, 0, negative 1, 0, 1, 0, 0, 1. I mean, I could go on forever. I'm not going to, but I could. Okay, so now 2 pi gets 0. Now look, watch this. See that? Look at what's happening. There to there, there to there, there to there. Okay, what does the graph kind of look like?
Zigzag.
A zigzag. Nobody said that in period 4. Zigzag. Okay, gotcha. All right, can I tell you this? Sine functions and cosine functions are very, very smooth on top and smooth on the bottom. They're not like this. Boom, boom, boom. They're not jagged. They're smooth. So they don't go like this. They don't do that. They're smooth as a baby's butt. So they're going to do what?
Great.
They're going to go up, 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 up. Then they smooth out. And then they come down fast. And then they smooth out. And they go up fast. Okay? That's what they look like. Now, on the back side, it's the same thing. What about negative pi over 2? Where do you think that one's going to go? Negative 1. What do you about negative pi? Back to 0. What about negative 3 pi over 2? Up to 1. What about negative 2 pi? Back to 0. So you know what? To me, I talk about, it looks like you're on a what? A roller coaster. I always say roller coaster. You guys said zigzag. Period 4 said it looks like a snake.
Hills.
Hills, valleys. Okay. Okay. Here's the deal. It always looks like this. Okay. What's going to change this? Watch my hands. What's going to change it is a compression, and then it goes like this. Just goes up and down really fast. Or a stretch, which means it kind of takes its time going up and down. Or you can vertically do what? Stretch it or vertically compress it. We're going to do all that stuff. Yes.
Wow.
Yes, Roshan.
I was stretching.
Oh, okay.
I can't tell how high it goes. Alright, well.
It's coming. I'm going to tell you. Can you wait? Because I got the next slides coming.
Is it way does that have to do with your A and B?
It does. It does. It's all coming though, Brady. All right. Brady's getting ahead of me. Hang on, guys. Ready? Let's move, shall we? Oh, by the way, this was what function? Sine, but it was the easiest sine function I can give you. It's called the parent. I did the parent with you. Okay. Now we're going to talk about two things. One of them is something what Brady was talking about, and then the other one is this one. What's the period of the sine function? Now the period is, you know, when you think roller coaster, think like this. I'm on the top of the roller coaster. A period is when I'm on the top. When do I get back to the top? Right here. So how long did that take me horizontally? Did that take me 2 pi? Did it only take me pi? Did it take me half a pi? How long? So what's a period? It's the horizontal length of one cycle. So here's me thinking, all I gotta do is get on the curve somewhere and wait until I get back to the top. Well, I'm right here. Well, the period is the horizontal length from here to here. That is the period. How far is that? Well, right there to right there. Can you see it? That's negative pi. That's negative 3/2 pi, right? That's half a pi. So how far did I really travel here? What's the period? 2 pi. Now Brady says it, but do you see it, guys? That is 2 pi. Could you have done this? Could you have done bottom to bottom?
Yep.
That's still 2 pi, right? How about the middle of the roller coaster to the middle of the roller coaster?
I don't know.
Kind of?
Yeah.
Well, you can't go to like the next middle.
Are you saying because I hit the middle, that's the period? No, because watch. Look at your answers. Start at 0. Your answers are all positive, 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 positive. Hit that same point. Guess what? After this, they're not positive. They're what?
Negatives.
Now they're negatives. Now right about here, aren't all of these answers repeating these answers?
Sure.
Yeah. See, that's what it is. It's when do you start repeating the answers? Right there. Do this one. This doesn't take long, so you should probably be done by now. I think this one's a little easier, I think. If I started here, top to top, how far was that? That's half a pi. How do you know? Because this was 0 and I went to half a pi. So, Bryce, question? Question? No, stop talking. Here's the deal. Pi just got what?
Smaller.
Compressed. You guys know. Pi. What did I say pi for? Sine just got compressed. Sine is normally, the sine function, the parent function, has a period of, you know,
16.
the period of the parent, go back, here's the parent. Look at the parent. How long before we repeat on this one? I go 0, up, 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 down, down, down. Oh, look, I'm in the same point, but wait a minute. We're not repeating answers. Positive, positive, negative, negative. Oh, here's where we repeat our answers. So it's from there to there. What is the period of sine? 2 pi. It's always 2 pi, okay? Unless something happens, and I'll show you what's going to happen. Okay? All right. There. Now, Brady, this is where it comes. Amplitude. Amplitude. What's amplitude? They give you a nice little formula, but it's so easy. Half the difference, there's the half the difference between the maximum and the minimum values of the function. Yes, Brady?
Does this have to do with sound?
Yeah, kind of.
Amplitude, that
Yeah.
has to do with like that's what you plug into a guitar, like in that.
Yep, yep.
Into,
Yeah, amplitude has a lot to do with sound.
Those are like sound waves.
Yep.
That's what it reminds me of.
Yeah. Rice.
Yeah.
I'm up here. Okay. You're right, Brady. Here, guys, I got to show you something. This is how easy this is. If you take your maximum, you subtract your minimum, and then you take half of it. Well, first of all, the maximum your wave goes is that number, what? 3. This number's what? -3. So really subtract the maximum and the minimum, and then take half of it.
3.
Well, what's 3? Minus 3. 6. Half of 6. 3. But to be honest, it's not that hard. I wouldn't even use the formula. Just look at it. Where do you start looking and where do you go? Amplitude. Highest point is, okay, but where do you start looking? Where?
Isn't it called the crest?
The crest up
The
here?
trough.
Okay.
The crest.
Okay, you must be getting into science terms, right? Oh, chemistry. Okay, here's what I do. I go right to the middle. I call it the midline, the middle of the roller coaster, and I just say this. How high up did I go? 3. How far down did I go? 3. So the amplitude is what? 3. The amplitude is just midline up. The highest you go is 3 up from the midline, and the lowest you go is 3 down from the midline. And the amplitude will always be positive. It's always positive. Okay?
So the next one is 0.5.
Yeah, see, now it's so easy. Don't even use the formula.
What's?
What's this one? 0.5. Because the midline is right here, and if you just go up and down, well, look here. You're only going up 0.5, right? Amplitude is pretty easy. Okay? Okay, guess what? It's the same problem I did with you on the first slide. It's the parent. Okay, so there's not much to tell you, but I do have a couple things to tell you. Okay? What?
We have to graph.
No, we're not going to grab it. I'm just going to tell you a couple things. You see this A? That A is the number in front of the word sine. That A will stand for what?
Yeah.
Amplitude.
Yeah.
Okay, here's the deal. Amplitude just means how high up from the midline, how low down from the midline. That's all it means. If this number is 2, you'll go as high as 2 and as low as -2. What's your number now? 1. What's your highest you're gonna go? And the lowest you're gonna go. That's why I put 1 and -1 there for you. That's why I did that. Okay? Now, you see this B?
No bees.
You what?
There's no bees.
No, there's a B there. It's there, I'll show you. But you know what that B does? That B does this. It pushes your sine function in, called a compression, or it does this. Stretches it out. That's called, stretches your sine function. Now, your B right now is what? 1. If your B is 1, then the period of sine is, what's the period going to be of sine? 2 pi. I already did this function with you. You should know it's 2 pi. Look on your front page. It's always 2 pi. Okay, now, here's what you don't know. You don't know this. When you graph, you need to make a table. Okay? And when you make a table, you start with 0 radians. But what you guys don't know is, what am I going to count by? What am I counting by? What's this number, this number, and this number? Because I want to break it into 4 equal parts. So what you do is you pick 5 points. They're known as what? 0, max, 0, min, 0. What's next? Okay. Now, the max and the min, it's the amplitude. If the amplitude is 1, the highest you'll go is 1, the lowest you'll go is -1. So really when I say max and min, it's just whatever the amplitude was. Okay? Now, here's the only thing you need to know on this slide. Ready? Well, there's a couple things. You need to know 2 pi is your period all the time. But come here now. Divide the period 2 pi into what? 4 equal parts. Well, that means take your period, cut it in 4 parts, and what does that mean now? Yeah, 1/2 pi. What does that even mean? That would be called your, on your graph, your intervals. So that's what you're counting by. So when you start making a table, you go, I'll start at 0, then I'll start counting by what? Pi over 2, which is 90 degrees, by the way. So it's what? Try what? 90 first, then what? Count by 1/2 pi's. Pi, then what? 3 over 2 pi, then what? 2 pi. One more, guys. What comes after 1/2, 2 halves, 3 halves, 4 halves, 5 halves? Pi.
Why'd you do that?
I just wanted to show you that it keeps going. It just keeps going. Okay. All right, you ready? See these words? You either trust me, or if you don't trust me, you take every one of these numbers and you stick it into the sine function. And I already did this with you on the first slide. Here's what I'm trying to tell you. Your first answer is what? Your second answer is your max.
1.
Yeah. How'd you know it was 1? Because the amplitude is 1. The third answer is what?
0.
Back to 0. Then what? Minimum, then back to the max, then 0, -1, 0, +1, 0, -1, 0, +1. He just repeats and keeps repeating. And then if I graphed it, I mean, if I'm graphing by myself, it's just put your intervals down. It'd be this. Don't do this because you did this on the first slide. You don't have to do this. But all it is start where? 0, 0, then go where? Pi over 2, up 1, max. Pi is 0. 3 pi over 2, -1, minimum. Back to 0, back to your max, and it goes like this. Where would it go after this? Back to 0, then where? Back to 0. Right? It goes on forever. Okay? Say what? Say good, say bad. Don't get it? Sort of get it? Kind of? Okay. This is the parent. This was supposed to be easy for you. Now, let me see the time we got here. 1:03. No, it's not worth it. Okay, here we go. Here's what I'm going to tell you. You did 50-60% of what you need to know. I'm not sure, because I haven't looked at your assignment, but you might only be able to answer 4 questions, 5 questions. You probably can't graph any of them, I don't think. Maybe you can do the most basic one, but I don't know if I'd waste my time. Which the bad news is, here's the good news. You don't have much to do. Just do what you can do. The bad news is, tomorrow's assignment will be bigger because you didn't do much today, other than listen. Tomorrow when you get in here, we're going right here, and we're graphing these right away. There'll be no question. I'll just go. So this is graph paper. It's kind of weird looking, but you need a couple. Okay? So why don't you grab a couple? Okay. There you go. I don't want to do this.
Hey, Mr. Painter. Mr. Painter.
Yeah.
Here's my.
Oh.
Thank you.
How'd this go? How'd this go? Good?
Yeah.
Oh, you sure? I mean, it looks like you got some good work here. I'm just asking. Hey, hit the lights, Haley. Will ya? Thank you. Oh, yeah, yeah. Okay. Brady, I know you got a busy weekend. I get it. Maybe Saturday night you're still far going, right?
Yeah.
Gosh. Okay, mainly Sunday. Come back and look at day 2. Once you get Sine, it's supposed to be really about the same thing. It's like I ripped through Sine on Friday pretty quick. So if you can watch the 2 videos, here's Friday version. Graph posting, we have in the top posting. And graph Sine, so there's 10 to graph. Then I say, here's some graphs, write the equation.
Okay.
But you don't know how to do this, because I haven't got this far yet.
Yeah.
So really, this looks like gibberish to you, but maybe by Sunday if you watch the video. Okay. All right. Sorry. Oh, you probably want here. You probably want 1, 2.
I grabbed it.
Oh, did you already grab them?
Like 4 or 5.
Yep, then you're good. You're good.
What she did yesterday. I feel like everybody does that now. You have to. But some of them also.
You ready? And good luck.
Thank you.
Like right before you left, you should have pushed like this, like 4 guys like that.
Are the hockey players gone again?
I don't think so.
Hey, I could only do some of the questions on the homework because I didn't get any notes.
All right, let's see. 3 people here.
Yes, we get to eat.
No, we don't.
Hey, did you get my homework yesterday?
We did. How'd that happen?
I brought it to this lady.
this lady.
She was in here during.
Oh, we missed Schmidt.
What period was it?
Oh, Bundy?
6.
No, it was during English. It was
Fifth.
during third period.
Okay. Yeah, somehow I think I got it.
Why'd you say fifth?
I don't know.
No, it's not.
That's this end. No, that's last.
Did you put it in the G book?
It's in my grade book, not in the computer though, but I got it. I got it.
when you stayed after class that one? Yeah.
Well, you had to read.
Were you yelling at Nick?
What?
When you
stayed after class?
When you had a stone taken away, I like, pull out.
On it?
Yeah, you should have.
You need a blue line with two black lines to make it look cooler.
Do we have 3 people?
Yeah.
We do 3 people.
Told you.
It'd
be so
What period is this? 5, 6,
Hey.
You know what? Go. If you go that way, Sam, no, last one on the left. Ask that lady. I don't know, I'm sorry.
Definitely, wait.
Sit down, sit down.
Yeah, Nick was just wondering what the house report that we got in our table tonight.
What was that?
Yeah.
You want to see my cup?
It's not mine, but I'm going away.
Thank you, John Roy.
Are you doing this done?
So is this, does that mean like,
Plates,
cups
cups
are
are on
plates
the
now?
What about the food?
So like food?
No, no food. Sorry.
Do you have any
I know-
straws?
I know you're starting to drool
You
right
should
now,
have
I can
let us
tell.
actually cut it into a pie, and I'm like, it was a pie.
Yeah. I'm not hungry for pie.
Okay, so we're missing today. Oh,
That's house.
That's yours. That's yours.
where you going? You don't listen.
You put your cup on your table,
Which way are we going, this way?
on your chair.
No, no. Well, oh, I see what
You
you're
can't
saying.
fold it.
You can fold it.
I have a
Either
question,
way,
Mr.
it
Baker.
doesn't matter.
Dagger bar with.
Can I move the backpack?
I can't see.
It's
terrible
With the
history.
Raven-
Hey, can I sit next to Nick?
No, you don't let me do it. I'm gonna take 5 minutes.
This is you. I actually want to sit in the back.
No, we're going.
You know what
Going in.
No, I still don't know what it is.
You're behind.
Here comes the 3
I'm
pieces
sitting
to the
You're
9.
really behind.
Follow.
Okay, you see this?
Jagger bar. Holy crap, how can you do that?
You and I did this yesterday. Carlos, you okay?
Yeah.
Okay. Hey, nobody sit down. Okay, you and I did this yesterday. We made a circle, the unit circle, and we put degrees and radians all over the place, didn't we? Okay, well here's what I want you to do. You're gonna start by, we're gonna do it all over again. We're gonna cut our paper plate in half. Okay. Crease it well, because really you're gonna open this up and then you're gonna have nice lines. Okay. Then we're gonna do it in half again. Now, this is about where you should be now, right? Right?
Rick, you're so far behind, bro.
That's hard to pull the cup.
Okay. Next, you're there, right? You got a quarter of a plate now, right? Next, do it again. Cut it in half. You went from half a plate to a quarter plate, now to what? An eighth of a plate. You're down to an eighth. Okay.
These are pretty hard to pull. Are you done?
My wife did this with her class.
How old are they?
They're third graders.
Yeah, Nick.
Alright. I'm just kidding. They're more like second. Okay, you ready? Guys, you're down to an eighth of a plate. Now, that's as far as we're gonna go because we're gonna pencil in 30s and 60s and all that. We'll pencil in it. If you open. Okay, now you got to pick. Where's the X and where's the Y axis?
This is so not even.
Well, come on.
Come on.
What, did you get to the eighth part?
I think.
Okay, look, that's an eighth. Okay, then you open it and now you got lines all over the place. Okay, yeah. Now, go there. Here we go. Okay. You got that paper plate in front of you, right?
Yep.
Now, pick a line.
Whoa, I think you're right.
This is hard to see.
Watch.
You guys, you pick one line, vertical and horizontal, and you take your pencil and you just do this. Draw yourself a nice, along your crease, that's your x-axis,
Can you like,
that's your y-axis.
can you like cut some of the cup off the sides so it's like more flat?
You can do whatever you want to do, but I'm just trying to get you going, okay?
Alright.
Now, do you notice my line quit early? I didn't go to the edge of the plate because I'm gonna ask you to do this right in this spot. You're gonna say, this would be 0 degrees, which equals, how many radians? 0 radians, right? I made that a little too big, but whatever. 0 degrees is in the same spot as 0 radians, okay? So now, what you have to do is start drawing these lines. So, we're gonna do this. What do you think this one is right here?
90.
No, these right here.
45.
These are your 45s. So, what I would do to start with is get those 1, 2, 3, 4 lines in and draw them all the way through the origin. So now you have actually 8 pieces of a pie. And then if I were you, I'd start putting your angles in right now. 0 degrees. I hope you understand that's 90. That's 180. 270. And now I'm back to 0, but 0 and something else are the same thing.
360.
Okay? So you got 0 degrees and 360. Okay. Now, of course, I want both things. I want the radians to go with it. Have you guys drawn your lines by now, I hope? You're with me, right? I know it's hard. I know how hard it is. I feel sorry for you guys.
You should have got softer plates. These are kind of hard
Oh,
colors.
okay.
Someone's gonna try.
Now, this is 90. Oh, I'm sorry. Go back to 0 degrees. 0 degrees is how many radians?
0.
0 radians. You have not traveled around the circle. Next would be, let's go over here because this is pretty easy, I hope.
3.
180 degrees is how many radians?
3
1 radian.
pi.
Guys,
What?
isn't that 3.14 radians around the circle? So we call it pi.
Yeah.
Okay, now keep going all the way to here, 360. What's this?
2 pi.
2 pi. Okay, got it. I did what I consider probably the easiest 2. 3. 0 radians, pi radians, 2 pi radians. Well, if all you do is go around the circle halfway up here, half of this number,
Half pi.
half a pi. Well, I always read it like
Pi over 2.
pi over 2. Okay. Now, if a quarter circle is half a pi, and a semicircle is a pi, what's this going to be? Right here.
3.
1.5 pi.
It's 1.5 pi, but write it like this. I always write it as an improper, 3/2 pi, which is 1.5 pi. Okay, we got the easy ones down. These are called the quadrantals, by the way. The ones that lie right on the x-axis and the y-axis. Okay, let's do the what?
45.
45s. Okay, now remember, you guys should be writing kind of small here to fit all this in, because we got a lot more to do. So if I say 45, if I add another 45, I'm at 90. Another 45, I'm where?
130.
135, yep. Another 45 would be 180. Another 45 would be
225.
225. Another 45 gets you to 270. Another 45 gets you to what?
350.
315. Okay. So we got the angles down in degrees. Now let's do radians. Well, okay, 45. How many 45s fit into a 180?
4.
1, 2, 3, 4. So 45 is 1/4 of a half a circle. When it comes to radians, how are you going to write that?
Pi over 4.
1/4 of pi is pi over 4. So you have 1/4 pi right there. Well, guess what you can do now? Start counting by 1/4 pi. Here's 1/4 pi. Here's 2/4 pi, by the way, that's half a pi. Here's what? 3/4 pi. Here's 4/4 pi. Here's 5/4 pi. Here's 6/4 pi, but 6/4 reduces to what? 3/2. Here's what? 7/4 pi. And then if I go one more 45, that'd be 8/4 pi, but 8/4 is really 2 pi. Okay. So guys, we're missing some good angles. What are the good ones? 30/60s, right? The 30/60s. I'll go a different color for you. How about red? And here's my question. Where's 30 gonna fall? Closer to 45 or closer to 0? Closer to 45. So just get it closer. Don't get it over here. You know, somewhere like right here. So that's a 30. Where 60 would be closer to 45, right? So that's a 60. Okay. Now we got to talk about 30s. When it comes to 30, how many 30s fit into 180? 6. So this is 1/6 of 180. When it comes to radians, this would be 1/6 of pi. So I would write it like this. Pi over 6, 1/6 pi. Then I'd go 30 degrees more, right here, up to 60. I just count by 1/6. 1/6 plus 1, that'd be 2/6, right? But what's 2/6? 1/3. So that 60 is just pi over 3. 1/6, 2/6, 3/6 is pi over 2. Next would be what? Uh-oh, I don't even have the degree here. What's that degree? That's a 120. You guys will count by 30s, aren't we? 30, 60, 90, 120. Equals 1/3, or sorry, 1/6, 2/6, 3/6, 4/6 is what? 2/3 pi. Okay, you guys, get the next one. I forgot, I'm still recording from last hour. I don't think I need to record 2 classes.